So now what happens if we just talk about general functions? Well, with polynomials, it's very easy. All these polynomial functions right here are nice, continuous, well-behaved functions. And so these are certainly the kind of functions that we could evaluate by direct substitution. And all of these rules are useful in showing why, whenever we take a limit, we can employ these rules to indicate it. So for example, right here, and I'm just going to illustrate these rules right here on the right with this first example, are saying the limit as x approaches 2 of a function like 3x squared minus 2x plus 1 is really the same by our sum and difference rule right here as saying taking the limit as x approaches 2 of 3x squared minus the limit as x approaches 2 of 2x plus the limit as x approaches 2 of the quantity 1. And then employing this constant multiple rule right here, we can take these constants away from our first two terms and take 3 times the limit as x approaches 2 of x squared minus 2 times the limit as x approaches 2 of x plus the limit as x approaches 2 of the constant 1. And now we can go up to our basic rules right here. We said, in order, the limit as x approaches c of x to the n is equal to c to the n. Well, this is like saying 3 times 2 squared minus 2 times the limit as x approaches 2 of x. The limit as x approaches c of x is always equal to c, so in this case, that's 2. And finally, the limit as x approaches 2 of 1, well, that's our first rule right up here, the limit of a constant as x approaches c is just equal to the constant. And you can see that the effect is the same as if I had just substituted in 2 right from the get-go. And we're going to get 3 times 4, which is 12, minus 2 times 2, which is 4, plus 1, our result, is equal to 9. Not too bad. So, all right, all of this work is not necessary, but we definitely want to know these particular rules anyways because we're going to use them later. So bear them in mind, but by direct substitution then, I can say my limit as x approaches negative 1 of the quantity x squared minus 5 is the same as the limit as x approaches negative 1 of x squared minus the limit as x approaches negative 1 of 5. Well, we know how that's going to work out. That's going to be the same thing as saying negative 1 squared minus 5, which indicates that our limit is going to be 1 minus 5 or negative 4. Or if I wanted to evaluate this limit as x approaches 5 of negative 2 times x to the 4th is the same thing as negative 2 times the limit as x approaches 5 of x to the 4th. By our direct substitution rules, it's going to be negative 2 times 5 to the 4th power. Well, 5 to the 4th power, having worked this out with knowing that 25 squared is the same thing, it's 625. And so my result is negative 1250. And there we go. So solving these kind of limits is really, really easy by direct substitution.